Exercise 78, question 1. So I've drawn out the problem, a rectangular block, and I've drawn the dimensions on 40 millimeters by 20 by 15. You've got to find the capacity of the block, or the volume of the block, and then its mass. So actually, if we think about the mass, first of all, that will help us for the first bit, because to find the mass, we need to use the formula. Density is mass over volume, given here. This symbol here, rho, is often used to represent density. So this is part of the Greek alphabet, and the symbol is rho, R-H-O, like a curly P, used to represent density. If I rearrange this formula for the mass, I get that the mass is density times volume. So we have to multiply the density by the volume, and if you look at the density is grams per centimetre cubed. So the key thing is this centimetres cubed. That means I need the volume to be in centimetre cubed, and at the moment the volume is in millimetres. So before I start, I would convert all my dimensions to centimetres. So I'd call this dimension 4 centimetres, this dimension 1.5 centimetres, and this 2 centimetres. So then when I work out the volume, I get the volume in cubic centimetres. I could work in cubic millimetres, but then I have to remember how many cubic millimetres there are in a cubic centimetre, and that's not 10, because for volume it's 10 by 10 by 10, which is 1,000. So I could find the volume in cubic millimetres and then divide by 1,000, but it's easier just to get all your dimensions in the correct units at the start. So now if you carry on, you could work out the volume, and then once you've got the volume, you can put that value in here with the density to get the mass.